Hi, this is Mrs. Young, and this lesson is a continuation of our review on our functions packet. This is our third day of reviewing the lessons that we've covered in functions. So I'm going to start by going over your homework. Then I'm going to review the last two lessons with you that were in this packet, and then I'll even help you start your homework. So checking over our homework started on page 37. We had to do 12 through 20. So starting with number 12, we had to tell whether the equation was linear or nonlinear. So you can see that A and D are linear. They're in that slope-intercept form, y equals mx plus b. And you can see that the two in the middle, B and C, are nonlinear. They're not in slope-intercept form. Numbers 13 and 14, are these linear or not? How do I know why or why not? So I can see in number 13, every time the x value goes up by 2, the y value is going up by 1.8. That's a constant rate of change. So yes, that is linear. In number 14, every time the x goes up by 2, I can see first the y goes down by 4, then it goes down by 4 again, so it looks linear, but then the last part right there, it goes down by 12. So that's not a constant rate of change, so it is nonlinear. The graphs, remember I mentioned this yesterday, I think these are the easiest. Number 15, that is not a straight line, so it's nonlinear. And then number 16, for sure that's a straight line, so that is linear. So again, easiest I think on the graphs, probably most challenging are the tables. And then on to the second part of our homework, number 17, we had to write the equations from the graph. Again, I thought this was easy because it was review. I can see in that first one, I have a y-intercept of 6, and then you draw a little slope triangle. You can see on the y-axis, you're going by 3s. So when you go up 2 squares, that's 3, 6. And then you run going across 1, so 6 over 1, or 6 is your slope. So I wrote y equals 6x plus 6. Again, maybe you wrote y equals 6 over 1x plus 6. That's okay too. Remember, slope is rise over run. In number 18 from a table, again, I'm going to use 2 points to calculate slope. I didn't want to use the fraction. I just don't like fractions. So I used the first order pair and then the third order pair in my slope formula. So I had -3 minus a -4. So that's -3 plus 4. That's 1. And then in the denominator, I have 0 minus a -5. That's 0 plus 5, or 5. So I have a slope of 1/5. And then remember I said to find your y-intercept, you look for an x value of 0, and that corresponding y value is your y-intercept. So my y-intercept is -3. So knowing your slope and y-intercept, you can write the equation y equals 1/5 x minus 3. And then in number 19, again, a graph, so a little bit easier. I can see this has a y-intercept of 700. I did my slope triangle down 300 over 4. That actually could reduce. 300 divided by 4 is 75. So we simplify or reduce our slope to -75, or -75 over 1. So our equation is y equals -75x plus 700. What does the slope mean in context of the situation? Remember I said look at the labels on your graph. Remember that it's rise over run. So it's the amount owed per month. So it's how much Jeremy must be paying off his dad, $75 per month, because the amount he owes keeps going down. And then what does the y-intercept mean? He must have started out owing him $700, right? So he must have borrowed or owed him $700. Then number 20, the last one in your homework, we have a table. So again, I took the first 2 points, did my slope formula. I have a slope of 8.75. And then I can see with an x value of 0, my y value is 599. So that's my y-intercept. So we have y equals 8.75x plus 599. What does the slope mean? Again, it's the change in y over the change in x. It's the cost per shirt. So each shirt must cost $8.75. What does the y-intercept mean? Again, where it's crossing the y-axis, that's our cost. That's a starting out cost. So that must be the upfront cost or initial charge for the shipping. So $5.99 for shipping. So that was a quick review of your homework from last night. Today we're going to take just a little bit of review notes on the last two lessons. So on lessons 5 and 6. I'm going to use the back of my packet. It doesn't have a page number on it, so I'm just calling it page 42. If you have room on the other page that we were taking notes on, like if you still have room on page, I don't know, I think it was, let me double check here. Yeah, I was also putting notes on page 35. So if you still had notes on, or space on page 35, you could use that page. So we're going to just take a little bit of notes reviewing the last two sections here of this unit. The first one I'm going to talk about is lesson 5. Lesson 5 was definitely, I would say, the most challenging lesson in the packet. Here we were trying to write equations. So the first thing we talked about was how to write an equation if you're given a point and a slope. So writing an equation from a point and a slope. So if I give you a point and a slope, can you write the equation? So there were 3 steps that we did. The first step that we did is we substituted in the m, x, and y values into slope-intercept form. We substitute those into y equals mx plus b. Once we substitute those values in, we go ahead and solve that equation for b. We've solved equations for b. You should know how to solve an equation. And then your last step, and this was the step that some of you forgot. I remember in our homework, some of you forgot to write down this last step. This is where you actually write down your equation. You take your slope and your y-intercept and write the final equation in slope-intercept form. I'm going to show you a little example, maybe over here to the side. We're going to just write down a little example. Let's say that I give you a slope of 1/3 and I give you a point of, let's say, 3/6. So again, given a slope and a point, can we write the equation? So the first thing we do is we substitute those values into slope-intercept form. So my slope is 1/3, my x is 3, my y is 6. So taking y equals mx plus b, we're going to plug in 6 for y, 1/3 for m, and 3 for x. So as I substitute in those values, I get 6 equals 1/3 times 3 plus b. Now we're on to step 2, where we solve the equation. So when I'm solving this equation, the first thing I do is I multiply those 2 pieces together. 1/3 times 3, 1/3 times 3 is just 1. And then if I want to solve this for b, get the b by itself, I'm going to subtract 1 from both sides of my equation. So get 5 is equal to b. When most of you were doing this in your homework, you had no problem solving for b. Excellent. But then some of you forgot, like I said, that last step, write the equation. So you want to take your slope and your y-intercept and write the final equation. So we're going to say y equals 1/3 x plus 5. So that's the equation of a line that goes through this point and has a slope of 1/3. So we can write an equation from a point and a slope. The other half of this lesson 5, which was a little bit trickier, was writing an equation from 2 points. And the only reason I say that it's a little bit trickier is because there was another step added in. So when we write an equation from 2 points, the first thing we want to do, anytime they give you 2 points, the first thing that you can do is solve for your slope. And again, we know how to solve for the slope by using our slope formula, y2 minus y1 over x2 minus x1. Once you solve for slope, then again, you can substitute the m, x, and y values into your slope-intercept form. Then you can solve that equation for b. And then finally, you can write the equation. So those last 3 steps, 2, 3, 4, are just like the previous problem. The only difference here is we added in a step at the beginning where you actually have to solve for slope. So it's just a little bit longer problem. Anytime in these videos, if you feel like I'm maybe going a little too fast, you can always pause it, slow it down, or rewind it if you need to. We're going to do an example of this over here to the side, just so you are aware of what we're talking about. Let's say that I give you 2 points. Let's say one point is 2, -8. And then let's say another point is -3, 2. And hopefully you know by now, anytime you have 2 points, your first go-to response should be, let's calculate slope. So my first point, this is my x1, y1. My second point, this is my x2, y2. And I'm going to plug those values into the slope formula. So we have 2 minus a negative 8 over negative 3 minus 2. 2 minus a negative 8, you know that's 2 plus 8, that's 10. Negative 3 minus 2 is a negative 5. So that gives us a slope of 10 divided by 5. That's 2, so my slope is negative 2. Now I have a slope, and I can use this slope and one of those 2 points up above to substitute into slope-intercept form. Honestly, does not matter which point you pick. Maybe just to be different this time, I'll pick this as my xy value. Again, here's my m value, here's my x and y values, and I'm going to plug them into slope-intercept form. Plug them into y equals mx plus b. So again, my y value is 2, my m value is negative 2, my x value is negative 3 plus b. Negative 2 times negative 3 is a positive 6. And then to solve that for b, I'm just going to subtract 6 from both sides. So I get negative 4 is equal to my b value. So again, using my slope and my y-intercept, I can write my equation. Y equals negative 2x minus 4. If I had used the other point as my xy value, I should have still come up with the same b value. It shouldn't matter which point you pick. The line, the equation of the line, represents a line that goes through those 2 points on a graph. If you really wanted to, you could take a piece of graph paper and graph it and see visually that it would represent that line. And then finally, the last lesson in this unit was lesson 6. Lesson 6 really just talked about analyzing graphs. Really more descriptions about what you're seeing happening when you're analyzing those graphs. Remember that the graphs can be increasing or decreasing, right? Whether they're going uphill or downhill, kind of like your slopes, right? Positive and negative. Also, our graphs could be linear. That's if something was going at a steady pace or steady rate, or they might be nonlinear. If someone had like an increasing speed, think about maybe you're in a car at a stop sign, and when you accelerate, you start out going kind of slow and then you speed up. So that would be like a nonlinear portion of the graph. Also, if there was like a horizontal piece, that means they stopped or weren't moving. So we're looking at different relationships in graphs. Again, that lesson 6, if you need to look back at examples, those are on page 30 and 31. For lesson 5, that was pages 24 and 25. So if you want to look back at a few examples as you're reviewing, that's a great idea. Finally, we're going to go ahead and start our homework. And I wanted to do a few problems with you to help you get started. Your homework tonight is on pages 38 and 39. I'm going to have you do 21 through 34. And I thought just to help you out, I would do 1 or 2 problems with you. So maybe I'll do number 23 with you as an example. Again, this is right out of lesson 5. So my m value, my slope is negative 8, my x value is negative 2, and my y value is 16. Plug these into slope-intercept form. So we have 16 is equal to negative 8 times negative 2 plus b. Negative 8 times negative 2, a negative times a negative, that's a positive 16. And then when I subtract 16 from both sides, I get a b value of 0. Could my y-intercept be 0? Of course, the line could go through the origin. But again, remember that we have to write our equation. So now we take this b value and this slope, and we write our equation. Y equals negative 8x plus 0. A lot of times you would drop off the 0, simplify it, or reduce it, and just say y equals negative 8x. Again, I would accept the answer written either way. And then finally, I'm going to do one more problem for you off the next page. Maybe one of these at the top where we have to calculate slope first. Maybe I'll do number 26. I see the big numbers and the negatives. Yeah, I'll do that one first. So again, 3 is my x1, negative 10 is my y1, 10 is my x2, negative 38 is my y2. I'm going to start by calculating slope. Negative 38 minus a negative 10 over 10 minus 3. Negative 38 plus 10 is negative 28. 10 minus 3 is 7. 28, I know 28 divided by 7 is 4, so this reduces to negative 4. Again, that's my m, or my slope value. And like I said before, I can use either point. Maybe I'll use that first one. This will be my x, y, and then this is my m. And I'm going to plug this into slope-intercept form. So I'm going to say negative 10 equals negative 4 times 3 plus b. Again, as you solve this, multiply negative 4 times 3 is negative 12. Since it's a negative 12, we want to plus it to the other side, opposite operation. So I get a b value of negative 10 plus 12 is 2. So using that y-intercept and my slope, my equation is y equals negative 4x plus 2. So again, both of those problems came out of lesson 5, but your homework goes all the way down here. This bottom part is lesson 6, so it goes all the way up through 34. So again, just a quick reminder that your homework is the last part of this review, pages 38 and 39, 21 through 34. And again, I did 2 problems for you to help you get started. Good luck, and I'll talk to you later. Bye.